the product of the vector, this power series, and I'm not just going to write 101, I'm going to say the scalar. 101, that is to say it's a real number. You instead of scalar, you could call it number. Someday, at some point in this class, we will deal with scalars that are not just real numbers, but let's not do everything in chapter 1. The product of the vector and the scalar is, well, what you do, of course, is you multiply. But this is just a notation for, I mean, this is kind of like if you write 5 times 3, well, then you would write 8 afterwards, right? And similarly, let's distribute that 101 to every term to get 101 over n plus 1, x to the n. All right, good. Now, we're asked, additionally, does that scalar multiplication change the interval of convergence? Well, let's talk about the interval of convergence of the original series then. By the, I'm going to go with the ratio test. The series 1 over n plus 1 x to the n converges for values of x, if x such that, now you might not have been that careful in your wording in your 21C class, but if you took it from me, I would have encouraged you to be that careful, such that the limit as n goes to infinity of the ratio of the n plus 1th term, 1 over n plus 1 plus 1, x to the n plus 1, that's the n plus 1th term, over the nth term, which has an n plus 1 and a, 1 over n plus 1, x to the n. Remember, you also need to put that in absolute values. You want to find where that is less than 1. That gives the interior of the interval of convergence, and that inequality is equivalent to the inequality. Don't forget your limit. The limit as n goes to infinity. And I am going to simplify. Let's see, I have flipping the fractions around, n plus 1 over n plus 2, and absolute value sign. All but one of the x's cancel, so x. And that needs to be less than or equal, just less than 1. And in turn, that is equivalent to, well, okay, so this limit, x doesn't move with n, and in the limit as n goes to infinity, n plus 1 over n plus 2 is 1. So this is the inequality, absolute value of x is less than 1, which in turn is equivalent to x between 1 and negative 1. Okay. And let's see, we do the same thing for this sequence. Converges for values x such that, and this time we'll have the limit as n goes to infinity of 101 divided by n plus 1 plus 1. That's the n plus 1th term. I put that in the numerator and I divide that by the nth term. It's 101 over n plus 1 x to the n. And let's see if this changes anything. That needs to be less than 1, and that inequality is equivalent to Oh, wait a minute, the 101s just cancel. Since the 101s will just cancel, and I encourage you to not denote canceling with slashes. The algebraic expression will be exactly the same, right? Good. So the radius of convergence does not change. So the took up a little too much room right there. Interval of convergence is not changed by scalar multiplication.